Hello everybody, welcome into another lesson. So today we are going to talk about the rational zero theorem. This is particularly useful if we have polynomial functions that we can't factor. You can use it on ones that you can factor, but you're doing more work than you need to. But if you can't factor a polynomial to solve for the zeros, you can use this, or if the rational zeros fail, you can always use a graphing utility, and when you graph the function, you can use the roots or the intercepts feature on there to find what the zeros are. But for today's sake, we're going to assume everything has rational zeros, meaning that we can use this. And also for today's lesson, we're only going to be concerned with the real zeros. Now, the next lesson, when we get into the fundamental theorem of algebra, we'll be concerned with a whole set of complex zeros. But let's say we have a polynomial here. F of x equals x to the third minus 8x squared minus 23x plus 30. This definitely can't factor, right? So we're out of luck on that. Well, the rational zeros theorem states that if you take p over q, which that p is the factors of the constant term, divided by the factors of the leading coefficient, your q, you'll come up with a list of rational zeros that could possibly be zeros. So how does this work is probably what you're wondering. So in this case, your constant term is 30. So let's come up with some factors of 30, right? Of course, you have plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 5, plus and minus 6, plus and minus 10, plus and minus 15, and then plus and minus 30. Those are all factors of your constant term divided by factors of your leading coefficient, which is just 1, plus and minus 1. So in other words, your possible rational zeros are going to be plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 5, plus and minus 6, plus and minus 10, plus and minus 15, plus and minus 30. Alright, so we found our rational zeros. Now what does this mean? Now we have to use synthetic division. And we have to, it's basically trial and error, see which one of these we divide it by that gives us no remainder, so we have a factor. So let's set this up here. So let's take our synthetic division. We have a 1 for that coefficient, a negative 8 for this coefficient, a negative 23 on this, and then a 30 on this. Alright, so basically we got to experiment here. So if let's divide it by a factor of 1. Let's do positive 1. So bring down your 1 here. 1 times 1 is what? That's 1. Negative 8 plus 1 is negative 7. 1 times negative 7 is negative 7. Well, negative 23 plus negative 7 is negative 30. And then 1 times negative 30 is negative 30, so 30 minus 30 is 0. Well, it turns out positive 1 is a factor. So what do we do from there? We can say then that x minus 1, because positive 1 is a factor, you have x minus 1 times the quantity of the x squared minus 7x minus 30 is equal to 0. So now we've reduced this into a linear and a quadratic factor. Well, we can probably factor that quadratic even further. So you'll have x minus 1, of course, times the quantity of, let's see, x minus 10 times the quantity of x plus 3 equals 0. So now you factor this into 3 linear factors, which means you'll have 3 solutions for x. Set each of the factors equal to 0, you would get that x equals negative 3, positive 1, and positive 10. And those would all be the solutions to this. X is equal to negative 3, positive 1, and positive 10. So basically we're using synthetic division to completely factor this out. And if we couldn't factor the quadratic, then of course we'd have to default to the quadratic formula. But your 3 solutions are x equals negative 3, 1, and 0. And I got more. I do have more, of course. Alright, I have about 5 more. What if we have, let's see, x to the third plus 2x squared minus 11x minus 12. Alright, so we have f of x equals x to the third plus 2x squared minus 11x minus 12. Well, let's go ahead and set up our rational zero. So take your p over q, which factors of 12 are, well, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, and then plus and minus 12, right? All over factors of that 1 for the leading coefficient, well, that'd just be plus and minus 1. So that means your rational zeros are possibly plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, and plus and minus 12. Alright, so now we need to basically do trial and error and see which one of these will give us a remainder of 0. So let's do our synthetic division. Coefficient on x to the third is 1. Coefficient on x squared is 2. Coefficient on x to the first is negative 11. Constant term is negative 12. Alright. Let's see here. Let's try a factor of 2. So bring down your 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Alright. Negative 11 plus 8 is negative 3. 2 times negative 3 is negative 6. Well, you end up getting a remainder of negative 18. 2 is definitely not a factor. X minus 2 definitely won't be. Alright. Let's try negative 2. So bring down your 1. Alright, negative 2 times 1 is what? Negative 2. 2 minus 2 is 0. Negative 2 times 0 is 0. Negative 11 plus 0 is going to be negative 11. Negative 2 times negative 11 is positive 22. Negative 12 plus 22 is 10. We have a remainder of 10, so negative 2 is not a rational zero that would work. Alright, how about 3? Alright, so bring down your 1. Alright. 3 times 1 is 3. 2 plus 3 is 5. 3 times 5 is 15. Negative 11 plus 15 is going to be 4. 3 times 4 is 12. Well, negative 12 plus 12 is 0. What do you know? Positive 3 is the rational 0 that fits. So this is going to break down into the quantity of x minus 3 times the quantity of x squared plus 5x plus 4 is equal to 0. Which that x squared plus 5x plus 4 can factor even further. You'll have x minus 3 times the quantity of x plus 1 times the quantity of x plus 4 equal to 0. And what do you know? You have 3 linear factors. So just set each factor equal to 0. You'll get x equals negative 4, negative 1, and positive 3. So those are the 3 solutions to this. X would equal negative 4, negative 1, and then 3. All right. Now, let's go on to a higher power one. Unfortunately, this process can be a bit time consuming. So let's see, f of x equals x to the 4th minus 3x to the 3rd plus 6x squared minus 2x minus 12. All right. So f of x equals x to the 4th minus 3x to the 3rd plus 6x squared minus 2x minus 12. This definitely isn't factoring. So let's set up our rational zeros. So take your p over q. Well, factors of that negative 12, you have plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 12. All over the factors of your leading coefficient, which is just 1, plus and minus 1. So now you have a grand possibility of, for your rational zeros, plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, and then plus and minus 12. All right, so now we've got our rational zeros. Let's go ahead and use synthetic division to figure this out. So take the coefficient on x to the 4th, 1. Coefficient on x to the 3rd is negative 3. Coefficient on x squared is 6. Coefficient on x to the 1st is negative 2. And then you have a constant term of negative 12. Why don't we try positive 1? All right, so 1 time, let's see, bring down the 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. 6 minus 2 is 4. 1 times 4 is 4. Well, negative 2 plus 4 is positive 2. 1 times 2 is 2. Negative 12 plus 2 is negative 10. We have a remainder of negative 10, so that 1 is definitely not a possible rational zero. And I can tell you, I don't think negative 1 is going to work either. You can almost look at it and see sort of what might work. So there's a good chance negative 1's not going to work either. So we could save ourselves a little time. So why don't we go to 2? Bring down your 1. 2 times 1 is 2. All right, negative 3 plus 2 is negative 1. 2 times negative 1 is negative 2. 6 minus 2 is 4. All right, 2 times 4 is 8. Negative 2 plus 8 is 6. Well, 2 times 6 is 12. Negative 12 plus 12 is 0. So what do you know? We have that x minus 2 is a factor. So now we have that x minus 2 times the quantity of x to the third minus x squared plus 4x plus 6 is equal to 0. Well, we have a linear factor, but then we have a cubic factor that also can't factor. So the bad news is we got to repeat the process. That's where this can get a bit tedious. So I'm going to bring all this up here to help us out. Let's now put this up here. So we'll have x minus 2 times the quantity of x to the third minus that x squared plus 4x plus 6, all that equal to 0. All right. So what does this mean? We got to repeat the rational zero test for this cubic factor. So for the cubic factor, do your P over Q. Well, the constant term for the cubic factor is 6, so you'll have factors of plus and minus 1, plus and minus 2, plus and minus 3, and then plus and minus 6 over the factors of your leading coefficient, which would just be plus and minus 1, which means then your possible rational zeros are plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. The only good thing that came out of this is that there are less to test. There's a lot less to test than the first time around. So let's do our synthetic division here and test these out. Alright, so x to the third coefficient is 1, x to the second is negative 1, x to the first is 4, constant is 6. Let's try 2 again. Alright, so bring down your 1. What is 2 times 1? That's going to be 2. Negative 1 plus 2 is positive 1. 2 times 1 is 2. 4 plus 2 is 6. 2 times 6 is 12. So 6 plus 12 is 18. We have a remainder of 18, so positive 2 definitely isn't a rational zero. But what if we try negative 2? I wonder. Never hurts to try, because after all, a lot of this is trial and error, unfortunately. Let's just slap a negative on here. Alright, bring down your 1. Now what is negative 2 times 1? That's negative 2. Negative 1 plus negative 2 is negative 3. Negative 2 times negative 3 is positive 6, so 4 plus 6 is 10. Negative 2 times 10 is negative 20. Well, 6 minus 20 is negative 14. Bad news is negative 2 is not a factor either. All right, let's try 3. Bring down your 1. What is 3 times 1? That's 3. Negative 1 plus 3. That's going to be 2. 3 times 2 is 6. 4 plus 6 is 10. 3 times 10 is 30. So 30 plus 6 is 36. That definitely doesn't work. As a matter of fact, I think we should go for our 1s, because it's not looking so hot for negative 3 either. It's really not. Let's go for our 1 factors. Now let's try negative 3, then we'll go for our 1s. So bring down your 1. Negative 3 times 1 is negative 3. Well, negative 1 plus negative 3 is going to be negative 4. Negative 3 times negative 4 is 12. 4 times 12 is 4 plus 12 is 16. Negative 3 times 16 is negative 48. 6 minus 48 is negative 42. Yep, so negative 3 is also not going to work. I really think the solution's with one of those ones. Alright, let's try a positive 1. So bring down your 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. 4 plus 0 is 4. 1 times 4 is 4. 6 plus 4 is 10. We have a remainder of 10, not a factor. How about negative 1? So bring down your 1. Negative 1 times 1 is going to be negative 1, while negative 1 minus 1 is negative 2. Negative 1 times negative 2 is positive 2. 4 plus 2 is 6. Negative 1 times 6 is negative 6. Well, what do you know? 6 minus 6 is 0. So we found another factor. So this is going to turn into the quantity of x minus 2 times the quantity of x plus 1, because if you do x minus minus 1, that'd be x plus 1, times the quantity of x squared minus 2x plus 6 is equal to 0. So now we have two linears and a quadratic factor. The bad news is I don't think this quadratic is going to factor. I think we're only going to have, we're going to have to use the quadratic formula. So let's set that up. So x would equal the negative of b, which is negative 2 is positive 2, plus and minus the square root of that b squared, which would be negative 2 squared, that's 4, minus 4 times your a of 1 times your c of positive 6 all over 2 times that a of 1, so that'd be 2. Well, let's look at this here. 4 minus 24, that'll give you negative 20. For today's sake, we only care about the real solutions. So the only two real solutions are going to be x equals negative 1 and positive 2. We don't care about the imaginary solutions today. X will just equal negative 1 and positive 2. Now in the next lesson we would care about those imaginary solutions, but we'll get to that at the time. Alright, so now, what if I throw in an x to the 5th? Yes, so we have x to the 5th minus x to the 4th minus 7x to the 3rd plus 11x squared minus 8x plus 12. This one's a doozy. So we have here f of x equals x to the 5th minus x to the 4th minus 7x to the 3rd plus 11x squared minus 8x plus 12. Well, let's figure out our rational zeros first. So take your p over q. Well, rational, let's see, factors of 12 are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, then plus and minus 6, and then plus and minus 12. over the factors of your leading coefficient, which would just be plus and minus 1. So therefore, your rational zeros are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, and then plus and minus 12. Now, we do our synthetic division and see which one of these works. So, let's set this up here. Coefficient on x to the 5th is 1. Coefficient on x to the 4th is negative 1. Coefficient on x to the 3rd is negative 7. Coefficient on x squared is 11. Coefficient on x to the 1st is negative 8. And then your constant term is a positive 12. Well, let's try 1. Alright, bring down your 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0. So negative 7 plus 0 is negative 7. 1 times negative 7 is negative 7. 11 minus 7 is 4. 1 times 4 is 4. Negative 8 plus 4 is negative 4. 1 times negative 4 is negative 4, so 12 minus 4 is 8. That's definitely not a rational zero that works, the positive one. So why don't we try negative 1? Alright, so bring down your 1. What is negative 1 times 1? That's negative 1. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is positive 2. Negative 7 plus 2 is negative 5. Negative 1 times negative 5, well, that's going to be 5. 11 plus 5 is 16. Negative 1 times 16, negative 16. Negative 8 plus negative 16 is negative 24. Negative 1 times negative 24 is positive 24. 12 plus 24 is 36. We have a remainder of 36, so that negative 1 also doesn't work as a rational zero. So let's move on. I know this may seem tedious, but this is basically a method you want to use if factoring fails. And then if this fails, you're almost exclusively going to solve it graphically at that point. You could still solve it graphically regardless, but you got to know how to do this. So that's why I got to teach it. Let's do positive 2. Alright, so bring down your 1. 2 times 1 is 2. Negative 1 plus 2 is positive 1. 2 times 1 is 2. Negative 7 plus 2 is negative 5. Alright, 2 times negative 5 is negative 10. 11 minus 10 is 1. Alright, 2 times 1 is 2. Negative 8 plus 2 is negative 6. 2 times negative 6 is negative 12. Well, 12 minus 12 is 0. So what do you know? We found a factor. So this can be written as x minus 2 times the quantity of x to the 4th plus x to the 3rd minus 5x squared plus x minus 6 equals 0. So we got a linear factor, but now we've reduced this down to a 4th degree factor. So we got to repeat this again. So let me write down where we're at with this so far. Alright, so now we have it that x minus 2, that quantity, times the quantity of x to the 4th plus x to the 3rd minus 5x squared plus x minus 6 is equal to 0. So there's your factorization to this point. Now we're going to repeat the rational zeros test for the fourth degree factor. So take your P over Q. Well, factors of -6, you have plus and minus 1, plus and minus 2, plus and minus 3, and then plus and minus 6. Over the factors of your leading coefficient, which would just be plus and minus 1. All right. Now, that means your possible rational zeros are plus and minus 1, plus and minus 2, plus and minus 3, and then plus and minus 6. All right, let's go ahead and do our synthetic division here. So coefficient on x to the fourth is 1, coefficient on x to the third is also 1, coefficient on x squared is -5, coefficient on x to the first is 1, the constant term is -6. Well, what better place to start than 1? So let's bring down the 1. 1 times 1 is 1. 1 plus 1 is going to be 2. 1 times 2, that is 2. -5 plus 2 is -3. 1 times -3 is -3. 1 minus 3 is -2. 1 times -2, that's -2. -6 minus 2 is -8. Definitely not a factor, so x minus 1 can't be a factor. All right, let's try -1. All right, bring down your 1. -1 times 1 is -1. 1 minus 1 is 0. -1 times 0 is 0. All right. -5 plus 0 is -5. -1 times -5 is +5. 1 plus 5 is going to be 6. -1 times 6 is -6. -6 minus 6 is -12. Well, that's too bad that didn't work out. It almost looked like it was going to work for a minute, didn't it? It almost did, but it didn't, unfortunately. Why don't we try 2? So bring down your 1. Now 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. -5 plus 6 is +1. 2 times 1 is going to be 2. 1 plus 2 is 3. 2 times 3 is 6. Well, -6 plus 6 is 0. What do you know? We have another factor. This can be written as x minus 2 times another x minus 2 times the quantity of x to the third plus 3x squared plus x plus 3 equals 0. So let's go ahead here and write everything up here, but I do have some good news for this cubic factor. You're going to see just how good it is in a second. So this will further break down into, if you have two factors of x minus 2, really this is x minus 2 to the second power times the quantity of x to the third plus 3x squared plus x plus 3 equals 0. Well, here's some good news. That cubic factor, we can definitely factor that by grouping. We don't have to do the rational zeros for that. We could, but it's more work than needed. We can do that by grouping. So let's take the x to the third plus that 3x squared plus x plus 3, well, what is that going to factor into? Look at your first two terms. You can factor out a common x squared, so you would get x squared times the quantity of x plus 3, plus then you'll have that x plus 3. You have a common x plus 3, so that means you're going to get x plus 3 times the quantity of x squared plus 1. So this can all be rewritten as x minus 2 to the second power times the quantity of x plus 3 times x squared plus 1 equals 0. So now we have the complete factorization. Well, x squared plus 1, that'll produce imaginary results, so we don't even care about that. We just got to figure out these other ones. X minus 2 equal to 0, that would give you x equals 2. X plus 3 equal to 0 would give you x equals negative 3. So your only real solutions are x equals negative 3 and positive 2. And that positive 2 actually occurs twice, so that would technically count for 3 real solutions. So x equals negative 3 and positive 2. I got just 2 more, but I think we'll go back to third powers. I think you've seen plenty how the higher powers work. Just know you got to repeat the rational zero test, which now you see why this can be rather tedious. Alright, f of x equals 2x to the third plus 4x squared minus 2x minus 4. Okay. This time the leading coefficient is not 1, it's 2. So let's do our rational zeros here. Take the p over q. What are factors of 4? Well, you have plus and minus 1, plus and minus 2, and then plus and minus 4. Easy enough, right? Now what are factors of that leading coefficient of 2? You have plus and minus 1, plus and minus 2. So what does this break down into? Well, start with your 1, start with everything divided by that 1. So that would give you, of course, plus and minus 1, plus and minus 2, and then plus and minus 4. But what else? You also have to account for everything up top divided by that 2. Well, 1 divided by 2, that's going to give you plus and minus 1/2. 2 divided by 2 is 1, 4 divided by 2 is 2. So don't forget to divide everything thoroughly. We actually do have to consider plus and minus 1/2 in this case. Yes, I know a lot of you are saying, wait, you can factor this. That is true, you certainly can, but I want to show you the rational zeros method for this. So let's do our synthetic division here. Let's take our leading coefficient, so 2, then 4, then negative 2, and then negative 4. Alright, so what if I try 1/2? I'll try positive 1/2 first. So bring down your 2. What is 1/2 times 2? That's 1. 4 plus 1 is 5. 1/2 times 5, well, that's 5/2. So negative 2 is negative 4/2. Plus 5/2 is, that's positive 1/2. 1/2 times 1/2 is 1/4. So that'd be negative 16/4 plus 1/4. That'd be negative 15/4 as a remainder. So positive 1/2 definitely is not a viable factor. Well, let's try negative 1/2. I don't know why I did that. I could just put a negative sign in front of it. Alright. So bring down your 2. Negative 1/2 times 2 is going to be negative 1. Now, 4 minus 1 is 3. Negative 1/2 times 3, well, that's negative 3/2. Negative 2 minus 3/2 would be negative 7/2. Negative 1/2 times 7/2, that's 7/4. Negative 16/4 plus 7/4, that'd be negative 9/4. Well, negative 1/2 isn't looking like a factor either. We have 6 other rational zeros to consider. All right, let's try positive 1. Bring down your 2. What is 1 times 2? Well, that's just 2. Now, 4 plus 2 is 6. What is 1 times 6? That's going to be 6. Negative 2 plus 6 is 4. 1 times 4 is going to be 4. Well, negative 4 plus 4 is 0. What do you know? We found a factor. So this would turn into the quantity of x minus 1 times the quantity of 2x squared plus 6x plus 4 is equal to 0. Well, with that quadratic term, you can factor out a common 2, right? So this would turn into 2 times the quantity of x minus 1 times x squared plus 3x plus 2 equals 0. Well, it also looks like that quadratic factor can factor. We can divide both sides by 2 to get rid of it. You'll be left with the quantity of x minus 1 times the quantity of x plus 1 times the quantity of x plus 2, all equal to 0. Now, what do you know? We have 3 linear factors. So x would equal plus and minus 1, and then you would also have negative 2. So your 3 solutions are x equals plus and minus 1, and then negative 2. At least we had all real solutions for this. I got just one more, then we are done for the day. Much to everyone's relief, I'm sure. But rational zeros, as you see, are a bit tedious, but sometimes it's the best you got. Good one. All right, so 3x to the third plus 12x squared plus 3x minus 18. Well, there goes the theory of factoring it by grouping, so that's definitely not going to work. So let's go ahead here and we shall find our rational zeros. So take p over q. Factors of 18 are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, and then plus and minus 18. All over factors of your leading coefficient of 3 are plus and minus 1, and then plus and minus 3. So what does this mean? Well, divide everything by the 1 first, so you could have plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, plus and minus 18. Now divide everything by 3. Well, you could have plus and minus 1/3. What else? You could have plus and minus 2/3. Then everything else, 3 divided by 3 is already 1, 6 divided by 3 is 2, 9 divided by 3 is 3, 18 divided by 3 is 6. We already have those. So there are your possible rational zeros. Now let's do the synthetic division. Alright, so we got 3, we got 12, we got 3, and then we got negative 18. Let's try 1/3 first. What is one? Let's see, bring down the 3. What is 1/3 times 3? That's 1. 12 plus 1 is 13. 1/3 times 13 is 13/3. Plus 9/3, that'd be 22/3. 22/3 times 1/3 is 22/9. Well, we can clearly see we're definitely going to have a remainder. As a matter of fact, I don't think the negative 1/3 or any of the 2/3 ones are going to work. So there's some good news for this. Why don't we try 1? None of the fraction ones are going to work in this case. I'm pretty sure of it. So let's just try 1. Bring down the 3. 1 times 3 is 3. Alright, 12 plus 3 is what? That's 15. 1 times 15 is 15. 3 plus 15 is 18. 1 times 18 is 18. Well, negative 18 plus 18, guess what? We have 0. We just got a factor then, since we have a remainder of 0. So this will become x minus 1 times the quantity of 3x squared plus 15x plus 18 is equal to 0. Well, good news is we could factor out a common 3 on the quadratic factor. Let's do that. You would end up getting 3 times the quantity of x minus 1 times the quantity of x squared plus 5x plus 6 is equal to 0. Well, we can divide both sides by 3. If you do that, you'll have the x minus 1 to start with, but that x squared plus 5x plus 6 will factor into the quantity of x plus 2 times the quantity of x plus 3. All that equal to 0. So now just set each of these factors equal to 0. You would get x equals negative 3, negative 2, and positive 1. So x equals negative 3, negative 2, and positive 1. And could we have factored out a 3 to begin with up here? Certainly we could have, but I wanted to show you very thoroughly how rational zeros work when you're testing them, that sometimes you'll have fractional rational zero possibilities. So that's it for this lesson. Next lesson, we're going to take all this. We're going to talk about the fundamental theorem of algebra, which will include the complex system for solutions. We'll explain what the fundamental theorem of algebra is and how it relates to that. So I hope everyone has a great day. Take care.